So when we think of probabilities, the formula for probability that something will happen is successes So when you're finding the probability, let's say we have a jar and we have 5 yellow marbles, 4 blue marbles, 2 green marbles, and 3 red marbles, okay? What I like to do is I like to put the categories. So you have 3 red, 4 blue, 2 green. It's going to be different, trust me. And 5 yellow, right? So if I tell you what is the probability of me putting my hand in that jar without looking and getting a yellow, what you do is you add up all of these marbles, which is 7 and 7, 14. So that's the total in the basement. So it would be 5 in 14 chance of getting a yellow. Does everybody understand that? If I wanted to know the probability of getting a blue or a green, that means blue and green are successes. So it would be 6 over 14, and that would reduce to 3 over 7. You would reduce it, okay? But today we're going to learn about things where you can use combinations, okay? And what you need to look at is if I got 4 blue and I needed to pick 5, then the 5 could have been, the 5th one could have been any of the other colors to be not a success. It would have to be a failure. So we're finding the probability of certain things happening in succession, okay? And if you read number 1, so if you have a total of 12 and you're going to pick 7 phones and 6 of them are cracked and 6 are not cracked, if you sell 7, what is the probability that exactly 4 will be cracked? If you have 4 cracked and you're picking 7, then you have 3 not cracked. So you put the category of total you have of cracked. Out of that total of 6, I need 4. I need to pick 4 because they want me to pick 4 cracked. And out of the other total of 6 not cracked, and these are not always the same number, the 6 and 6, I don't really like when they do that. 3 are not cracked, okay? Now in the basement, you always put the same thing. The total you're picking from, which is 12, and the total number you're picking, which is 7. So combination 6, 4 is 15, combination 6, 3 is 20, and combination 12, 7 is 792. Now put 15 times 20, which is 300, over 792, and reduce the fraction. What do you get?
7 and infinite 87.
So 0.3787, and what's after?
Infinite repeating.
87, okay. So if it's 0.378787 repeating, then you're going to move this decimal over 2, so it's 37.88%, rounded to 2 places. So on number 5, it says you are dealt 5 cards. So we've got a total of 5 cards dealt. Standard and shuffle deck of playing cards. Note that the standard deck has 52 cards. So total 52 cards in a deck. I take little notes and then it's easier. And 4 of those are kings. What is the probability that you'll have exactly 3 kings in your hand? Is that a hand that's hard to get 3 kings out of 5 cards? Extremely. So I would expect this probability to be a very low percent, because if it was easy to do, people would win poker games all the time. So you have 4 kings and you have 48 not kings. If we have 52 cards and 4 of them are kings, 48 are not kings. Does everybody understand that?
Yeah.
So of the 4, I need 3. And of the 48, I need how many? If I'm picking 5 cards. I get 3 kings. I need how many more? 2 more. That have to be not kings, because they want exactly 3 kings. You got it? And then it's over 52, which is the total number of cards in the deck, comma 5. So go ahead and see if you get that answer. So you get .00, you're moving it over 2 places. So you have less than 1% chance, way less, to get that hand. That's why if you get 3 kings in your hand, you can bid